All right, so I kind of ended this video here because it was getting a little bit long, but I'm going to just pick up where I left off, and then I'll go over to the next slide. So I remember I said that the circumference of a circle, which is the distance around the circle, right? So if I want to measure, I start here and I want to measure how long that length is around this circle. That's equal to the diameter of the circle, right? Which is the distance from, one side of the circle to the other. That multiplied by pi tells me the circumference. And we know, of course, that pi is around 3.14. Okay, so that basically means that I could take the diameter of my circle, right? I could take the diameter of my circle. Oops, let me delete this. And I could take 3 of those. Copy. Paste. And then I'll paste one more. Take 3 of those and I could wrap them around my circle, and that would give me the exact circumference of my circle. Oh, sorry, not 3, but 3.14 of them. So there would also be like a little 0.14 extra, 0.1415, whatever the rest of the digits of pi are, and that would give me the circumference of my circle, okay? Well, I could also split it up into radius, right? It would be a radius, a radius, a radius, a radius, a radius, a radius, and then an extra little 0.28, roughly, right? Because it would be basically, instead of pi times the diameter, it would be 2 pi times the radius, right? And 2 pi is 6.28, okay? All right, or I guess this, if I want to be accurate, this piece would be the same size as this piece, because now this right here is 0.14 diameters. This right here is 0.28 radiuses, which is the same, the same size. Okay, anyways. So what is a radian? That's the question. A radian is if I were to take one of these radii, I guess would be the word. We're getting into some weird words. Radii, like that. If I were to take one of these and I were to wrap it around my circle a little bit, what angle would I get here where this origin would intersect my little arc length that I created with my radius or my radii? Okay, and this is not super important, but it is important to note that there are 1, 2, 3, and then a little 0.14, roughly, radii in 180 degrees, which is why there are pi radians in 180 degrees. And then if I were to go around again, I would get another 1, another 2, another 3, and then another 0.14. And that would give me 6.28 radians in a full rotation, or 2 pi radians. And that's exactly why this point here is not only 0, but it's also 2 pi. So 2 pi radians means that there are almost exactly 6.28 of these little radii that I could take 1, 2, 3, 4, 5, 6, and then an extra little 0.28. And that would give me one circumference, or one full rotation around my circle, okay? So hopefully that makes sense. I just wanted to explain radians in case people don't know what they are or why we use, radians sometimes. A lot of the times it's just because to memorize radians is a little bit easier. Keeping everything in terms of pi versus degrees when you're doing math can oftentimes make things cancel out and make the math work out very nicely, especially when it gets into calculus and doing integration and derivatives with and trig identities also are often memorized in terms of pi, sometimes degrees, but they're interchangeable. Some people prefer degrees, some people prefer radians. It really doesn't matter how you do it as long as you stay consistent. But a lot of times the radians can be more convenient mathematically and can cause some things to cancel. So I just wanted to kind of briefly cover that. I think the next slide I was supposed to do some stuff on, but since we've kind of beat the unit circle to death, I think I'll probably stop. Maybe I'll throw some of my next notes on this slide, but I'm going to go ahead and end this video here. and hopefully the unit circle is now clear. This has been a pretty thorough review, and I think it's very relevant for what's going to come next in terms of AC signals and AC sources in this class. Okay, so I'm going to go ahead and stop this video here.